Welcome back to Math 130. We're still in section 13.1, exponential functions. Here are three exponential functions, and they are written the way you should enter them into your calculator, which is what I want you to do now. Please pause the video, enter these into your calculator, look at the graph, and then come back. No, enter all three and graph them all together before you come back. Seriously, stop the video and graph them. Your graphs from your calculator should look like this, although they will not be in those pretty colors if you're using the TI-89. I would like for you to go ahead and graph these as well. Okay, and this one. So that you can see some other graphs, you might also try this one. You can explore further on your own. Before we leave this page, I want to note that all of these original three functions go through the point 0, 1. So in those equations where it follows the pattern y equals b to the x, we're looking at y equals b to the 0, which is always going to be 1, which is really what that coordinate pair says. Moving on. Let's talk about the characteristics of the exponential function. All right. So the exponential function, well, we can write it two different ways. Y equals b to the x, or f of x equals b to the x. The domain is all real numbers. That can also be written as x is an element of the reals, and that's what that symbol means there, element. Or it can be written as negative infinity to positive infinity, put in parentheses because we can never reach either negative or infinity or positive infinity. Likewise, the range is y greater than 0, or it could be written with parentheses so that it stretches from 0 to positive infinity. Next, we can recall that the base must always be positive. Has to be greater than 0 also, and b will not equal 1, because that's just not very interesting. It's always equal to 1. To talk about the next characteristic, I will have to introduce a new vocabulary word. That word is asymptote. The definition of an asymptote is the do not cross line. But really, it's the do not even think of touching line. Practice social distancing from that line. Actually, that's what the function does. You're just noticing its strange behavior. And finally, number 4, as x increases, b to the x increases if b is greater than 1, and b to the x decreases if b is less than 1. You just graphed some examples of those. Moving on. Okay, let's look at problem number 42 from your book. It's about earthquakes. The intensity I of an earthquake is given by, and then it gives you this equation. Number 42. Here's an application problem. Right, the intensity of an earthquake is I. Okay? So what's I? Well, they tell you how you can calculate I. This I sub 0 is the minimum intensity for comparison. Okay? Unfortunately, your book does not even tell you what that means, minimum intensity for comparison. But if you did know that, if you had that reference number someplace, then you could figure out what the intensity is if you just knew R, which is the Richter scale value, Richter scale value of the earthquake. So this is a slightly different measure than the Richter scale. You're using the Richter scale to calculate the intensity. Anyways, the problem in your book asks you to evaluate I in terms of I sub 0 if R equals 5.5. So we've been given a value for R. So let's rewrite the equation with that value inserted for R. And then we can at least evaluate part of this on a calculator. So with a calculator's help, I have determined that I have 316,227.766 I sub 0. A lot bigger than the minimum intensity that we have for comparison. All right, that's all I have for today. I'll see you next week.